Hello, welcome back on my YouTube channel. Welcome back on Physics Corner. Yes, today I have one paper about Cambridge International AS and A-Level Physics Paper 1 multiple choice in year 2020, February, March. Yeah. And I said to solve some question here. Yeah. Hopefully 40 numbers. Yeah, hopefully, but I don't know. Hopefully 40 numbers. Yes, we have this question. Oh, no. Why? Oh, we have also mark scheme in here. Why I provide mark scheme here? Because I just prove it here. I just find the solution. I just find the solve. Why the answer is like number 1 is C, number 2 D, number 3 D, and so on and so on. Okay, let me check one by one. But before we continue, please don't forget to subscribe. And if you like this channel, if you like this exam style, please press the button like. Okay, let me check number 1. Yeah, number 1 we have answer is C. Yeah, we have answer is C. So I will highlight the answer is C. Why answer is C? Yeah. Okay. The table shows some measurable quantities. Which row give the correct order the magnitude of measurable quantity in the state unit? Okay, this is the table about measurable quantity and order of magnitude. Yeah, and then the units one. The unit, I think, correct, yeah. Mass coin in kilogram, thickness in meter, weight in Newton, and temperature in Kelvin. With temperature 10.10 power 1 Kelvin. Is it not correct? Yeah, why the temperature person is about maybe 37? Yeah, so it's like not correct. Yeah, and then mass of coin 10 minus 4 kilogram. This is same thing with 0.1 gram. Also this is not measurable. Yeah. And then the thickness is 10 power minus 2 meter, same thing with 1 centimeter. Oh, no, this is not correct also. And the answer weight of apple 10.0 in Newton, it's mean like divided by gravitational acceleration. Yeah. Let's say the gravitational acceleration is 10. Yeah, so same thing with 0.1 kilogram. Same thing with about 100 grams. Yeah, so this is reliable or measurable. Yeah, weight of an apple is about 100 kilogram. Yes, it's correct. Yeah. Now question two we have answer is D. Yeah, so I will highlight about the answer is D. Yeah, and also number 3 is D also. uh, so let me check about number 2 and 3. Yeah. A byte or B compares it bits. How many bits are in the terabyte? Okay, terabyte is 10 power 12. So yeah, this is about 10 power 12. Yeah, so the answer between C or D. But this is in 8-bit. Yeah, so the answer is correct. 8 times 10 power 12. Yeah, bits. Because 1 terabyte equals to 10 power 12. Okay, number 3. Which pair quantities contains scalar and vector? Scalar and vector. Scalar, they don't have any direction. Vector, they have direction. Yeah. Acceleration, vector. Momentum also vector. Charge is scalar. Resistance, scalar too. Yeah. Kinetic energy, scalar. Mass also scalar. Temperature, scalar. Velocity, vector. They don't have any direction. Velocity have direction. Yeah, so correct. The answer is D. Okay, let me continue number 4 and 5. 4 is C, 5 D. Yeah. Okay. 4 is, I will move down here, this one. Yes, number 4 is C. Yeah, number 4 is C. Yeah, and then number 5 is D. Yes, let we check number 4 and 5. The transmitter emits a pulse of electromagnetic wave towards a reflector. Yeah, the pulse is reflected and returns to the transmitter. The detector located at the transmitter. Yeah, the emit pulse and the reflected pulse are displayed on the cathode ray oscilloscope or CRO. Yeah, as shown. The pulse takes 6.3 microseconds to travel from transmitter to the reflector. What is time base setting CRO? Wow. Time base of CR. So when 1 centimeter, yeah, what? Okay. Transmitter emit pulse electromagnetic wave. Betul. The pulse is the okay. When we see this is like this is a signal, yeah. This is the signal, and then this is the reflector. Ya. Kakak Jaki, lihat nggak apa-apa. Kakak Jaki lihat waktu nak. This when we see one way is 6.3 divided by 3 because this is 3 times, yeah. So this is same thing with 1.2. Sorry. This is same thing with 2.1. Yeah. One way in, this is in microsecond per centimeter. Yeah. So when they have a reflection also, this is like 2 times, yeah. 2 times 2.1, yeah, microsecond per centimeter. So this is something with 4.2, yeah, microsecond centimeter minus 1. Yeah, it's correct. Okay, now what about question 5? Question 5 is D. A micrometer is used to measure diameter to cylinder. Diameter of a cylinder 12.78 plus minus to 0.02 millimeter. Diameter of second cylinder 16.24, 0.03 millimeter. The difference in diameter is calculated. Yeah. What answer in the of differences? Okay, the answer is 0.05 or D. Yeah. Okay. What is answer then? This is like uncertainty as the adding. Yeah. Let's say we have P equals to Q plus R. So delta P over P, this is like something with Q over Q plus delta R over R. So it's meant like we adding, yeah, this 0.02 and 0.03. It's meant like delta P means delta Q plus delta R. Yeah. So this is something 0.02 plus 0.03. Yeah. It's equal to 0.05 in millimeter. Yeah, so the answer is D. Okay, now about question 6. Yeah, question 6, the answer is, we check. Question 6 is D. Yeah, question 6 is D. Question 7 is A. Yeah, so D, and then question 7 is A. Yeah. Okay, now we see question 6. A stone is thrown horizontally from the top of cliff and falls into the sea below. Air resistance is negligible. The path of the stone is soft. Okay. In which direction does resultant force on the stone act during its falls? Yeah, because there is no force on the x direction. Yeah. On the x direction, there is no force. They only have force on the y direction and downward. Yeah, this is about weight. Yeah, or mg. So this is only vertical downward. There is no force on the x direction or on the horizontal direction. Yes, correct. Okay, question 7. A car moves in uniform acceleration along straight road. Oil leaks from the car at the rate of 1 drop every 2 seconds. The diagram shows the distance between three successive oil drops on the road. What is the acceleration of the car? Okay, the answer is A. Yeah, the answer is A. We can see here, this is rate of 1 drop every 2 seconds. Yeah. Rate 1 drop every 2 seconds. Okay, so we see this, yeah, about every 2 seconds. Yeah, this is 9/2. This is velocity 1, let's say. This is about 4.5, yeah, meter second minus 1. And then velocity 2, yeah, yeah. This is about 12/2, yeah, so 6.0 meter second minus 1. So when we find about acceleration, this is V2 minus V1 divided by T. This is 6, yeah, minus 4.5 divided 2 seconds. So this is 1.5 divided to what? 0.75, yeah, meter second minus 1. So correct answer is A. Okay, let me check question 8, 9, and 10. Yeah, 8, 9 first. Yeah. Scroll down about answer. Yes. 8 is D and 9 is C. Yeah. Okay. D and 9 is C. A person of mass 60 kilograms stand on accurate bedroom scales placed on the floor of an elevator lift, which operates is in a tall building. At a certain instant, the bedroom scales read 58 kilogram. Which row call give the person's direction movement and the type of motion. Oh, okay. Let's say this is lift. Yeah. This is lift, and this is person. So the person, they have weight and the rate of bedrooms. Yes. Okay. This about 60 and okay. Hmm, when we see, yeah, about this one, yeah, uh, and okay, the first one, when they have constant speed, this is wrong. Yeah, this is wrong. And downward, slowing down. I think this is about slowing down because the bedrooms plus they have 58 kilograms. So they have normal contact force here. Yes, this is like normal contact force minus W equals to MA. Uh, normal minus this is 60 G, yeah, equals to, oh sorry, yes, 60 G equals to 60 A, and they have normal context like 58 G minus 60 G equals to 60A. Yeah. So A means negative 2G over 60. This is accelerate. Yeah, decelerate. Decelerate. Yeah. So it's mean slowing down. Yeah. It's mean slowing down. Yeah. Slowing down. But not downward. Yeah. Why? Because if downward, this is like W mean N equals to MA. Yeah, this is like 60 G minus 58 G, yeah, equals to 60 A. 2G equals to 6A. So A equals to 2 over 60 G. Yeah. This is accelerate. Yeah. When they upward, this is decelerate or slowing down. Yeah. So correct. The answer is D. Question 9. The diagram shows graphs of various quantities plot against the time for an object drop from a stationary balloon high in the atmosphere. Yeah. Which statement cloud is correct? Yeah. We have 4 graphs. Yeah. And the answer is 3. Graph 1 is accelerate against time. Graph 2 resultant force against time. Graph 1, yeah. But this is go to constant, yeah. So something with uh, acceleration against time, acceleration constant. Grade 3 is resultant force against time. This acceleration. Oh, yes. Grade 3, the acceleration constant. The grade is slowing down until the constant. Yeah, this is when the acceleration is 0. It's mean like constant velocity. Yeah, and grade 1 is velocity against time. Yes, this is go to the constant velocity. Yeah. So we can say the slope or like gradient is slowing is go to small gradient. Yeah, so yes, correct. This is acceleration. Yeah, and this is velocity. Yeah, acceleration become to 0. Yeah, and velocity becomes to constant. Yeah, yeah, because this is uh object drop from a stationary balloon height in, yeah, in the atmosphere. Yeah, so they have uh, acceleration in the first and until the time, uh, and they have constant velocity. Go to the constant velocity. Yeah. Yes, correct. The answer is C. Okay, now we try to see question 10. Yeah, 11, 10 and 11. We see the first. I scroll down. Yeah. Number 10 is B and 11 is A. Yeah. So 10 is B, 11 is A. Okay, the diagram show particle P traveling at speed V. Yeah, about the collide with the stationary particle Q in the same mass. The collision is perfectly elastic. Yeah, this is perfectly elastic. And then they have same mass. Yeah, which does mean describe motion P and Q immediately after the collision. P come Yes, P come to rest and then Q same thing with velocity of P before they have collide. Yeah, yes, this yeah. So after they have, yeah, this is like P is come to rest. Yeah, this is P, and then Q. Yeah, they have velocity. Same thing with P before collision. Yeah, it's about V. Yeah, so correct. Answer is B. Question 11. A particle is in a uniform field. The particle experiences a force in opposite direction to the field. In which type of field in the particle and which property of particle is the field acting? Opposite direction. Oh, let's see this one here. Opposite direction. Yeah, good file. So type of field and property particle. Yeah, this is about charge, yeah, about charge. And also, yes, electric, not gravitational acceleration, because they have, yeah, particle. Yeah, this is about, because opposite, yeah, opposite, yeah. But gravitational, this is, if gravitational is mesh, yeah, yeah. So correct, the answer is A. Okay, now question 12, 13, and so on. We see first about answer. 12 is A, yeah, 13 is B. Yeah. So I will highlight first. 12 is A, and then 13 is B. Yeah, that's it. A uniform rod of weight 20 Newton and length 2.0 meter is acted upon by two vertical forces as shown here. Okay. We have 15 and 5 Newton in different position. What are resultant force acting on the rod? Result moment about the center of gravity of the rod. Okay, center of gravity of the rod is in here. Let's say on, and the rod they have 20 Newton, 20 Newton, and the length is 2 meter. Yeah. So resultant force, yes, resultant force equals to on the upward is 15 plus 5.0 and negative 20. This is become 0. Yeah, 0 Newton. So between A or B. And Russell moment, yeah, total torque uh, on the O, yeah, see, this is like 15 times because they have length too, so this one is 1.0 meter, 1.0 meter distance here, 1.0 negative times 1.0. So 15 minus 5 equals to 10 Newton meter. Yeah. So this one the correct answer. So the correct answer is correct A. That's it. Number 13 is B, which diagram shows the direction of the force such the block called in equilibrium. Yeah. I think this the length on A, B, C differently. Yeah. Okay, this is about three coplanar force act on the block, which diagram shows direction force in equilibrium. The answer is B. Why B? Mm. Oh, let me check about a random about C. The equilibrium is when total force equals to 0 and total torque equals to 0. Yeah. So I think this is total torque not equal to 0. Yeah. The C, yeah. Total torque not equal to 0 because they have rotation there. Yes. So not this one. Yeah. Yeah. What about this one? This is also, yeah. I think when they have rotation, I think this is also equals not 0. Yeah, because they have there and they have there also. So this is also not the answer. What about this one? This acting on the position, and I think uh, total torque on this position not equal to 0 2. Yeah. Yes. Over this one, the answer is this one. Mm. Oh, this one, yes. Why? This because this fractional force and this one, yeah, they have working on this point on the center. So they only have this one and this one. and the distance is like D, this is D and this is D. Yeah, let's say if this is F and this is F, this is like FD minus FD. Yeah, so equals to 0. Yes, correct in D. Yes. Okay, now see question 14, but I will move down about the answer key. Yeah. 14, 15, 16. Let me check. Yeah. 14B, 15B, and 16B. Yeah. BBD. Let me highlight. B, B, D. Okay, let me check about 14. Y and YB. Yeah. A cylinder contains volume 0.012 meter cubic of gas pressure 1.0 10 power 5 Pascal. 400 joule of work done on this gas. With the pressure remaining constant throughout, what is the final volume of the gas? Oh, okay. When you still remember about work done, yeah, this on the constant temperature equals to P delta T. Yeah, for work done equals to P. This is final volume minus initial volume. They have a work for 100, 400 for work, and they have 10 power 5. Yeah, let's say 10 power 5, and we will to find V2, and V1 is 0.012. So V2 minus, this is about 4 3, 0.004. Yeah, 1 2 3, yes, correct, plus 0.012. Wait. What is final? 0.01. Contains volume of gas pressure of 100. Why? This is 400 divided by 10 power 5 equals to, this is 400 times minus 5. This is something with 400 5, 4 times 1, 2, 3. 0.004. This is correct. Plus 0.0. This is 0.016 meter cubic. This one, yeah. 14. 14 is B. No, I don't know. Let you check about this answer, yeah. Oh, I mistake about this one. This is on this case, yeah. Okay. I changed this one about volume. About volume. So this is um this is like um I changed this one. Here is 0.012 minus V2. Yeah. And also, so this is 0.004 equals to 0.012 minus V2. So V2 equals to, yes, 0.012 minus 0.04. This is equals to 0.0080 meter cubic. Yes, correct. P. Okay, what about question 15? A ball is thrown vertically upward of the surface on the earth. Yeah, this is thrown vertically upward. Yeah, from surface of the earth. Which statement describe energy of the ball rest through the air? Because upward, yeah, so velocity it will be decreases. Yeah, kinetic energy also in decreases. Yeah, gravitational inertia is increases. Yes, correct. Yeah, P. Yeah. Why? Because first one velocity, yeah, it will be decreases. Yeah, and height it will be increases. Yeah. So potential energy increases, kinetic energy decreases. Okay, now question 16. 16, the answer is D. A sledge of mass 50 kilograms sit on the snowy surface is pulled horizontally for 10 meters against frictional force 200 Newton. Then it is pulled horizontally across ice for 10 meters. Yeah. There is no friction between the ice and the sledge. It is lifted up vertically by 1 meter and finally carried back at constant speed to where it starts. During stage journey, most work done on the sledge. Hmm, so, so kalau if we see about this snowy, it's one, and then they have the first one. They have this is 10 meter, and they have frictional force about 200 Newton, and they have mass 50 kilogram. And there is a there is no friction between the ice and slip. If it is a particular 1 meter, this is 1 meter because they have 200 Newton in frictional force. Yeah, so this is not constant speed. Yeah, this is wrong. This is wrong. Being okay. Also, this one. Being lift up 1 meter also wrong also, yeah. Why? Because this one, yeah, because frictional force. Being pulled across ice. Mm, this is ice, yeah. Across ice for 10 meter, they have, this is snow, yeah. Oh, the force is about snow. They have Newton. And in this area, they don't have any friction here. There is no friction between ice and the sledge here. So this is no friction. So they have pulled, yeah, that's correct, yeah. They have pulled 1 meter across snow. Why? Because the 2000 is snow, yeah, snow frictional force, yeah. So they have like force, yeah, by snow uh, at 200 Newton. So across snow, that's correct, B. Okay, I hope you understand about this, yeah. Now we can see question 17 and so on and so on. 17 is A. We see this. Oh, yeah. 17 is A. I will highlight first. This is A. And 18 is C. 19 is B. Yeah. Okay, we check together. 17. An object is moved in vertically plane from X to Y and then from Y to Z. Yeah, X to Y. This is X, yeah. X to Y and then Y to Z. Oh, okay, yeah. So we start from here to here and then go to here. Yeah. The distance between various points are indicated on the diagram. Line XY and VZ are vertical. XY, yeah, this is vertical. VZ also vertical. Yeah. They have 3 meter, also 3 meter. The object with 20 Newton. Okay. How much gravitational potential energy does the object gain the moving from X to Z? X to Z. Potential energy um, depends by H, yeah. Potential energy means mgh, yeah. So this is I think about H, yeah. How decision asks about H. When they have weight, yeah, mg is 20 Newton, yeah. So H, it's mean from X to Z, because they only in, this is only, yeah, in 3 meter, this one, yeah. They don't have any relate about 4 meter, 4 meter, 5 meter, 5 meter, or 3 meter here. But they have only about H between Z and X, but in vertical line. Yeah. This is about 3 meter. Yeah. So this is something with 20 times 3. Yeah, 60 in Joule. Yeah, that's it. Yes. I hope you understand. Yeah. So continue to number 18. 18 is C. Let me check together. A car travels at constant speed of 25 meter per second up a slope. The wheels driven by engine exert forward force 3000 Newton. Total force due air resistance of friction 2100 Newton. The weight of car has component down slope 900 Newton. Okay. What is rate of which thermal energy is dissipated? Wow. I remember about power. Yeah. Power equals to FV. Yeah. But F is the resultant force. Yeah. Because they move on the slope of down slope. I think this is about 3,000 minus, this is 3,000 minus 2,100 and then times, is it 9? Yeah, times 25. Mm, 910 times 25, it's like 22. Wait, we have cross component down. Oh, sorry. They have component down here, component down. This is forward, yeah, and this is arrow system, yeah. So negative direction, and this is component down, and you see this up, yeah. So I will erase this one. Yeah. The first, they have force, three forces. The first one, they have up force 300, so 3,000 minus arrow system 2,100. Also, because component down, this is plus, yeah, times 25. So it's like 300. Yeah, this is 1, yeah, times 25. 18, yes, 18 times 25. Oh, 40. Yeah, wait, second. Oh, astaga. This is up, yeah. This is, sorry. This is up. So I will erase this one. This is negative, yeah, negative 900. Why negative? Because this is up and this is slope, yeah, down slope, yeah. So this is negative. This is up and this is uh, opposite direction and this is opposite direction also. So here, not 100, not 1,800, but 0. Oh, this is become 0. No. Oh, sorry. Okay, I back again with you. This is about wheel driven by engines. Iron resistance and friction. Okay, maybe this one here. If we calculate 2,100 times 25, this is about 5.25 times 4. Oh, this is about 3. This one is okay. Maybe this is about frictional force. Yeah, frictional force because they asked me about thermal energy dissipated. Yeah. Okay. The answer C from this one. The air system of frictional force from the wheel. Yeah. Okay. Uh, we go to the number 19. Number 19, a component rod is made by attaching a glass reinforced plastic rod and nylon rod end to end, so 1 meter, 1 meter glass. Okay. The rod have same cross-sectional area, each 1 meter in length. The Young modulus EP plastic is 40 GPa. And Young modulus E of nylon is 2.0 GPa. The component rod will break when the total extension reaches 3.0 millimeter. What the greatest tensile stress that can be applied composite before it breaks? Okay. Yeah. We need to find about tensile stress. Yeah, the greatest tensile stress. You see this here. This is force. This is also force. And then in different side. Yeah. When we remember force over A, this is equals to P. Yeah? This is something with modulus Young, yeah, times delta R over L. So let's say P of plastic. Yeah, this is something with A plastic, yeah, delta L of plastic over L plastic. Yeah. And also P of nylon, A nylon, yeah, delta L nylon over L nylon. Okay, no, because this is in different side, yeah. So it's meant like P, yeah, the greatest one is for P, yeah. This is they have, this is from plastic, yeah. So we can say this is P plastic minus P nylon equals to A plastic delta L plastic over L plastic minus A nylon delta L nylon over L nylon. Yeah. And this is about 40, yeah, giga, yeah, giga, okay, like 10 power 6 here. Delta L is, this is 3 millimeter, but yeah, this is in total extension, yeah, total extension. This is like we divided by 2 because they have for plastic and nylon. Yeah, so this is times to 1.5. Yeah, this is 1.5 times 10 power minus 3 because in millimeter divided by 1 meter because this 1 meter, this is also 1 meter, minus this is 2.0 times 10 power 6 and times also 1.5 minus 3 divided by 1 also. So this is 38, yeah, times 1.5 times 10 power 3, yes, 6 minus 3, 6 minus 3 divided by 1. Yeah. So this is about 57 times power 3 or 5.7 times 4, yeah, in Pascal. That's it. Yeah, the answer correct. Okay, now we see question 20. Yeah, and I will scroll down again about answer K. Yeah. For number 20, 21. and 22 maybe. Okay, 3 number. 20 is C, 20 C, B, A. Yeah. Okay, I will highlight first the answer. This is C, and 21 is B, and 22 is A. Yeah. Let me check together. The graph shown the linear force extension curve for a while may form a new composite materials. Okay, this graph force in y direction, and on the x direction is extension. Yeah. What is the best estimate? Yeah, best estimate for the work done stretching wire point P. The point P. Uh, you know about work done is a half k x squared. This is something k is f over x2, yeah, time x squared. So we can say this is like a half fx, yeah. This is something with area, yeah. Area set area of this, yeah. So W equals to a half of, on the P is 100, yeah, and then X is 2, yeah, in millimeter. So this is something with about 1.10 in joule. But if this has the triangle here, we have still area on this sheet. Yeah. So like just something with work done on the P, it's like 0.1 plus something, but yeah, maybe 0.11, but not 0.2. Yeah, it's too big here. Not also 0.10 because this is not triangle. So the answer is, so continue number 21. Yeah. 21, the answer is B. Why B? Let me check. Yeah, that would be. Okay. A wave frequency 15 Hertz travel at 24 meters per second through a medium. What is the best difference between 2.0 meter apart? Okay, let me check about relationship between velocity and frequency. Yeah. We have lambda. Yeah. Wavelength or lambda is velocity divided frequency. 24 divided 15 equals to 2. Oh, 1.6, yeah, or 2 point, sorry, 1.6. This is 1.6 meter. So when we have wave, yeah, this is like this one, and wavelength is this. This is about 1.6 meter. So when the point is 2.0 meter, that's in this point here. So we have still about this one. This is about a fourth, yeah, of lambda. Is it correct? Yes, correct. Yeah, because they have wavelength 1.6. So when 2 meter, this is something 1.6 plus uh, 0.4. Yeah. So 0.4, this is a fourth of lambda. Yeah. So yes, this is correct. Yeah. They are outpaced by quarter of a circle because yeah, this is like one circle. Yeah, one circle is one wavelength. Yeah. Not as a their plus 0.8. No, yeah. Yeah, that's correct. B. Then question 22. The answer of question 22 is A. Yeah, let me check. Which row describe longitudinal wave? Longitudinal wave and medium stroke width, and then medium. Yeah. This is parallel, not perpendicular. Perpendicular is uh, transverse wave. Yeah, this is for transfer wave. Yeah, and then the medium is here. Yeah, it's correct. Yeah, not vacuum. Not vacuum. Vacuum is like light. Yeah. Yes. This is correct. Now question 23. Yeah, let me check about question 23, but I will scroll down about answer key. 23, 24, 25. 23, 4, and 5 is BDD. Okay, I will highlight first BDD. B, D, and D. Okay. Okay, now 23. A sound wave is displayed on the screen of a cathode ray oscilloscope picture. The time by setting 0.5 millisecond per division. What is frequency of sound wave? The answer is B 670 hertz. Yeah. Okay. Now about frequency. This is I think relate with this one. Yeah. This is 0.50 millisecond per division. So when we see one wave, this is about 3 division. Yeah. So we can say, yeah, the period is 3 times of 0.50 millisecond is 10 power minus 3 in second. So this is something 1.5 times minus 3 second. Then frequency is 1 over T. 1 over 1.5 times 3. 3. So same things with uh, same thing with 100. I said 1000 divided by 1.5. 677, yeah, about 670 as it. Yeah, that's it. Okay, yeah. Okay, now question 24. An observer is situated at the top of tall tower. An aeroplane emits sound of frequency of 1000 hertz. Approach the observer at the speed 165 meter second minus 1. Yeah. The speed of sound 330 millisecond meter per second minus 1. What the frequency sound received by observer? Yeah. The answer is 2000 hertz. Yeah. Okay. Now I want to highlight first about the first one. The observer on the top, it's mean like zero velocity, yeah, or on the rest. Yeah. An aeroplane emitting sound frequency of, this is source frequency, approach. approach the observer speed. Okay, this is speed of aeroplane. So the speed of sound is 330. F observer, yeah, same thing with 330 divided by 330, and then aeroplane is approach. It's like plus, yeah. Sorry, minus, yeah, 165, and then frequency of this aeroplane is 100. So 1000. So this is this calculator. Oh yes, this is, I think this is two, yeah, 2 times of 1000. Yeah, this is something with 2000. That's it. Yeah, so D is correct. Now question 25. 25. What is the order magnitude of wavelength of microwave and X-ray? Oh, the answer is D. Wavelength of microwave and X-ray. And this is about, yeah, X-ray is 10 power minus 10. Yeah, that's correct. This is about, yeah, because so small. I think this is actually not correct. Yeah, too big. Yeah, this is too big. So this wavelength of microwave, yeah, yeah, it's about this one, because this is like visible light. Yeah, this is like visible light. Yeah, it's correct. Okay, now continue number 25, 26, 7, and 8. CBD. Now we'll highlight CB. Yeah. This is C and B. 26 is C. Oh, sorry. 26 is C. And then 27 is B. And 28 is D. Okay. A musical instrument is made using long tube with mouthpiece at one end. The other on the open flat. So a musician maintains stationary sound with, with a note at mouthpiece and an antinote on the other end. The lowest frequency sound instrument can produce. This is low frequency, and this is not at the mouthpiece and antinote at the other end. So this is actually because antinote on the other end, it's mean like uh, this is lowest frequency, so with sec other frequency, and then this is something like uh, 9 2, and then the second one is 3 times, yeah, 9 2, and the third one is 5 9 2. They have like 1 3 5 7 9, yeah, about with the lowest one. So you see this, yeah, 3 times 9 2, 5 times 9 2, and then the other one is 7 times 9 to, yeah, and then 9 times 9 to, yeah. This is like continue number, yeah. So we can see this 3 times 9 to equals to 27 6. Yes, this one 276, yeah. And then 5 times, this is something 45, and then yes 460 hertz, yeah. And then this one. So yes, correct. This is the correct one is this one. Yeah. Okay, now number 27. A water wave per stroke a gap between two barriers. Yeah. The wavefront spread out as shown. This is direction of travel of wave. This is wavefront and this is barrier. What is the name of phenomena? Diffraction. Yeah. This is correct. Diffraction. Not interference, not superposition. Yeah. Interference is in two or double slit, yeah, into slits or double slit. Superposition is when two or more source wave and join together. Yeah. And coherence is when the frequency and amplitude is constant and phase difference is same. Yeah. Yes, the answer, the best, and the correct answer is B. Okay, now question 28. The answer is D. Yeah. The table shows for possible combination value of laser wavelength, slit separation on and slit screen distance since two slit interference experience to show the interference of visible light on the white screen. Which combination will result in visible fringe being observed? Okay. Hmm. I still remember about double slit formula dV over L equals to lambda. Yeah. Oh, okay. Set separation is D. Yeah? This is about D. This is about D. And set screen, this is about L. So it means like 100 millimeter divided by 1. This is wait, set separation. Let me check when about configuration between 100 and 0.1, because this is something also. Let's say in this row, yeah, D, yeah, this is 100 millimeter, something with 10 power millimeter is minus this 1, yeah, and P divided by L is 1 meter, M although we don't know, and mm, This is time 10 power minus 7. So P likes M, yeah, 6 times minus 6 here. The M is like 1, 2, 3, and so on and so on. So I'd say when this one, yeah, on different side, this is 0.1 times 10 minus 3 P over L is 1 meter, sorry, 5 meter. And this is M, 6 times minus 7. P likes 30 times minus 4. This is like 3 millimeter. When the answer is D. Answer is, wait, I will check. Oh, 20. C. About mistake. This is C. Yes, correct. C. This is C, not D. Yeah. Yes, correct. This is reasonable. Reasonable. This is not correct. Why distance of fringe is like 6 times power minus 6? Yeah? This is so small. But this is reliable. Yeah, 3 millimeter. Yeah, between fringe. Yeah. Still reliable when in something like 3 millimeter, but it's like this one, yeah, is 6 times 10 power 6, not available. Yeah. So, okay, the correct answer is C. Okay, we go to number 29. Yeah, 29 is we highlight first. 29 is D. Yeah, 29 is D. Okay, let me check together. Yeah, 29 is D. Well, here is this one. Light of wavelength or lambda is incident normal on the diffraction grating as shown. This is second order maximum diffracting grating. Okay. The angle between two second is C. Yeah. Which expression gives spacing line of the diffraction grating? Oh, this is like so angle in here is C divided 2. And this is supposed to be 2. And then we have here like spacing line. So this is P. Yeah, this is P. So when you still remember D sine theta equals to n lambda. Yeah. So this is D sine C divided by 2 equals to uh, lambda n lambda. So D means, yeah, because this is spacing lines. Oh, this is D in here. They're asking about D. So D equals to n lambda divided by sine C divided by 2. So why n equals to 2? Oh, I know. Because when one wave is, this is equals to 1 and this is equals to 1 also. and join together n equals to 2. Yes. So D equals to 2 lambda divided by sine C divided by 2. That's correct. Okay, now continue number 30. 30 is A. Yeah, I will scroll down again about the answer. Yes. 30 is A. 31 is D. Yeah, so A and D. I highlight first here. This is A and this is D. Okay, now let me see about number 30. Two possible charge and one negative charge as all equal magnitude, yeah, are set at corner of the equilateral triangle, which diagram represents the electric field surrounding the charge. This is not correct. This is about magnetic field, yeah. This is about magnetic field. This is also for C. This is not about electric field. Yeah, this is about magnetic field on the what do you call it? Yeah. So direction is also wrong. Yeah, direction also wrong. Yeah. When you still remember the plus one and the negative one, the plus one is when the magnetic field, the electric field. Sorry, this is split out. Yeah, and then the negative is go to uh, the point. Yeah. So between A and B, why B is not correct? You can see this. Yeah. This is supposed to, why the direction is like same thing go to interaction attraction. Yeah, this is not wrong. Yeah. It's okay. This is correct. Yeah, but this is not correct. Yeah, the correct one is like this one. Yeah. This is a repel. Yeah, this is like repel. Yeah. So yes, that's correct. Yeah, the correct one is A. Now continue number 21, 31. Sorry, 31. Yeah, 31 is D. Yeah, let me check. A negative charge or drop is held stationary equidistant between two plates connected to a high voltage supply as shown figure. This is oil drop, yeah, between two plates. Then the question is, which charge would not increase the upward electric force on the drop? Decreasing the distance between plates will keeping the drop equidistant from them. The question is which charge would not increase upward electrical force on the drop? Oh, moving the drop closer to positive edge. Increasing amount negative charge on the drop. Yes, correct. This is correct. Yeah, this is correct also. Increasing the supply voltage is correct. Yeah, because yeah, like A equals to V over D. Yeah, decreasing distance and also increasing voltage. Yeah, and increasing amount negative charge. Yeah, same thing with about voltage. Yeah, and then moving the drop closer to the particle plate. It's not depends when this condition. Yeah. Okay, the answer is D. Okay, now continue to 32, 31 until 40. Yeah. We have still around for 10 more number. Yeah, 10 more number. We say about 32, 33, and 34. The answer is start from 32, DBD. Yeah. Okay. I will highlight about 32 is D, D, and then B for 33, and 34 is D again. Yeah. Let we check together about the answer. Yes. Electron move in a vacuum from the metal plate, another metal plate. As a result of this, there is electric current 48 microampere between two plates. How many electrons are emitted by first plate in the time 5.0 minutes? Okay, I think you still remember about current, yeah, means charge over time. And then charge is total charge of electron, yeah. So how many electron? N equals to I times T divided by electron charge. So N equals to 48, yeah, microampere. Yeah, this is micro. Time is 5 minutes, 560, yeah, divided by charge of electron is 1.6 times minus 19. Yes, you can see here 4.8 divided 1.6 is around 30. Yeah, 30 times 5. Oh, wait. 5 minutes. Oh, yeah. This one, I will cross about this one. This is, and this is about 30. Yeah. Is calculator aja. So 30 times 5, 30 times 5 times 60, it's about 9. Yes, correct. 9 times 10 power 16. Yeah. This is about 9.0 times 10 power 16 electrons. Yeah, that's it. So the correct answer is D. Yeah. Okay, now question 33. And then I will erase about this one here. I think you can pause about video and then you can take screenshot or anything or copy this and write. Okay, now number 33. The answer is 4 divided by 3. Yeah, 4 over 3. Why 4 over 3? We check together. A battery is connected to 3 resistors and resistance 12 ohm, 6 ohm, and 2 ohms. Yes, the current of the battery is 3 ampere. Okay. What is value ratio power dissipated resistor 6 ohm and power dissipated resistor 2 ohm? Yeah, 6 and 2. Yeah, 6 and 2. Okay, I will find about I. Oh, I already at 3 ampere. I think for power in the 6 ohm, this is about, I think we need to find about voltage on this. Yeah, wait. We have a resistor combination of this parallel is, yeah, between 12 and 6 is RP, yeah, 12 times 6 divided 12 plus 6. This is about, this is 3, yeah, 12 with 4 ohms. Yes, 4 ohm. Then we can find about V on the parallel. It's IR. I is 3 ampere. 3 times 4. This is 12 volt. Okay, I will use in different formula. On the 6 is we use V divided by R on the 6. And on the 2 ohm, I use I square R on the 2 ohms. Yeah. This is 6, this is 2. Yeah, V on the parallel one, we have 12. And then, oh, V square, yeah, sorry, V square. And then this is 6 divided by I square. I square is 3. 3 square. And then R is 2. So this like 12 square divided by 6, 12 divided by 2. This is 24 divided by 6 times 2. Oh, wait. 19. This is 18. Oh, yes, correct. Yeah. This is about 4.4 divided by, yes, correct. Okay, now go to 34. The answer is D. A manufacturer recommends that the longer the extension cord you use with electric drill, the bigger cross-sectional area of the cord should be. What the reason of recommendation? Yes, correct. Yeah, because if you still remember about R, yeah, about R, R formula was rho L over A. So resistance proportional to length and inversely proportional. Yes, that's it. Okay. Okay, this one, yeah, B is correct. So continue again, number 25. And I will scroll down again about answer key. Yeah, 35, 36 in this page. Yeah, 5 and 6. 5 and 6 is B and B. Yeah. So I highlight about 35 and 6, B. And also this is B also. Okay, let me check together about this question. Two batteries are connected together as a battery 1, battery 2, 12 ohm and 0.3 ohm. This is inner resistance here. 9 volt and 0.1 ohms. Battery 1 has electromagnetic force 12 and internal resistance 0.3, and battery 2 EMF 9 volt and internal resistance 0.1 ohms. What are EMF and internal resistance are a single battery that has same effect as the combination. Wow. Oh, I know. This is, they have junction. Yeah, they have junction in here. So on the I combination, it means like this is positive, and this is negative. So it's mean like 12 minus 9. Yeah, positive 12 minus 9 equals to positive 3. Yes, between this or this. And then about resistance also, yeah, are internal resistance, yeah, are total. Yeah, it's been like 0.3 plus 0.1, yeah, 0.4 ohms. Yeah. Yes, correct answer. Yeah, 0.4 ohm. Okay, that's it. Now we check question 36. Yeah, the diagram shows a circuit 6.0 volt and 0.1 ohm. This is through 2.0 ohms. This is voltmeter. Yeah. What is reading of the voltmeter? V. Yes. V is IR. Yeah. I 2.0. This is 2.0. And about I means V over R total. V is 6.0, and then our total is 0.1 plus 2.0. Yeah, this is something 6.0 divided by 2.1. Yeah, so we back again about this. Yeah, V. Yeah, reading of the voltmeter equals to I. I is 6.0 divided by 2.1, and then times R 2.0. Yeah, this is about 12 divided by 2.1. Yeah, about 5.7, yeah, volt. Yeah, this one. Okay, that's it. So now continue to number 37, sorry. 37, we check on the next page. Yeah. 37, they have answer as C. Yeah. We see on the one page with the 38. Okay, 37 is C. Yeah. I highlight first 37. And then 39 is D. Yeah, 9 is D. Okay, let me check. Yeah, 37 still in electric, dynamic electric. Yeah. In the circuit zone, the cell has negligible internal resistance. Which diagram show a potential divider circuit that can vary the potential difference PD across the length? Okay. Yeah, the correct one is this one C. Yeah. This is the correct one. Yeah. This is not correct, yeah, because this is like short electric. Yeah, this is not correct. And about this one, why you choose this is uh, cannot working, yeah, cannot working when the position like this one. And this is also this is like differences. It's wrong, yeah. So the correct answer is C. Yeah. Okay, 38. Yeah. The answer is D. Two alpha particle with same kinetic energy are moving toward are the deflected by a gold nucleus. Which diagram called show the path of the two alpha particle? Okay, the first one, yeah, this is gold. Alpha particle is positive, yeah, gold also positive. So between positive and positive, it will be repel. Yeah, this one, uh, this is like they want to attract. Yeah, this is like they want to attract. So this is not correct. Yeah. And this one also, I think, a little bit, yeah, like high velocity and small of charge. Yeah. So this is not correct. Yeah. This is also why, like they want to attract. Yeah, they want like to attract. Okay. And back again, and this is not correct. This one. This is repel. Yeah, because this is like near with the this charge. Yeah, this is like near. Yeah, but repel, so they have deflect. Yeah, and this one also deflect. Yeah, because they want to attract. Yes, this is correct. Yeah. They want to attract between them. Yeah. Okay, then still two more number, and then 39 and 40 is DC. Yeah, we check together. Go to 39 and 40. The answer is D and C. Yeah. D for 39 and C for 40. Okay, now 39, the equation represents the decay of nucleus X and Y, nucleus Y. What are particle P and Q? P and Q. Okay. I think about P, yeah, because you see this, yeah, this is A, this is A. So on the P, this is 0, also key 0 also. And then this one Z and Z minus 1. I think this is the positive one first, yeah. So become Z, and here is 0. So from this, yes, this is beta particle. Yeah, beta positive, yeah. Beta positive, beta positive. And Q is from why neutron? Actually, this is gamma, yeah. This is AAP. So this is 0 and 0. Why neutrino? Yeah. Let me check. D. Yeah, the answer is D. Is it like this is like gamma ray? Because they don't have any mass number or atomic number, 0 and 0. Because neutron, oh, this is neutrino. Yes, correct, neutrino. Not neutron, yeah. Neutron is 1 O. Yes, correct. Sorry. Okay, D ya. Neutrino, bukan not neutron ya. Neutrino, not neutron. Okay, the last one, number 40. Which row give correct type for composition for named particle? This is proton, hadron. What component? Type and yeah, see, I don't know still. This is up quark, down quark, yeah, up and down. Yes, okay. I think that's yeah. See. Okay, thank you very much for your watching until the end this number. And please don't forget to subscribe and like. Yeah. Thank you very much. See you on the other video.